Welcome to this episode of the Verilog Bench. Today we're going to be looking at the origins of the ATB protocol family. ATB is not a memory bus and not a simple control register bus. It exists to move trace information from sources towards sinks in a controlled way. Trace needs its own transport because trace producers and trace consumers are rarely perfectly matched. A source may suddenly emit useful debug data, while the downstream path may need to absorb it carefully. The heart of the original ATB transport is the valid and ready handshake. The source says data is available, the downstream path says it can accept it, and only then does the transfer advance. Flow control is not the whole story. A trace transport also has to preserve enough context so the sink can still make sense of what it receives. That is why the early issue talks about IDs and byte order. Flush behavior is another key origin point. Trace systems need a clean way to say drain what is left so the sink sees a complete picture rather than a truncated one. The easiest ATB picture to remember is sources, funnels, and sinks. ATB is the transport contract that lets those blocks share trace safely. The origins takeaway is that ATB was never meant to be just a raw byte pipe. It is a trace transport with explicit flow control, context, and drain behavior. If this ATB Origins video was useful, like and subscribe to be notified of future videos. Next, we move from issue A into the next ATB update. Before that, here is the glossary. ATB means Advanced Trace Bus. ATVALID marks valid trace data from the source side. ATREADY marks downstream readiness. And ATID is a trace identifier used to preserve source context. A trace source generates trace data. A trace sink consumes or stores it. A funnel merges trace from several sources, and flush means draining the remaining trace toward the sink.